Hello students, today we're going to solve a related rate type of problem. The problem states at noon a train leaves Bridgeton heading east at 90 miles per hour to Cogsville, 450 miles away. At 12:15 p.m. a train leaves Cogsville heading west to Bridgeton at 100 miles per hour. So in essence, train A has a 15-minute head start traveling east. At what time will the two trains pass each other? So let's add some detail to this diagram, and let's see here. Let's give train A and train B some vectors. Okay, so what I'm showing here is a vector that indicates the direction at which train A is headed. It's heading east, and then here's a vector that represents train B, and I'm showing the relative size of the vectors that indicate magnitude and direction of the speeds of the train. Now train A has a speed of 90 miles per hour, and that's east, and train B has a speed of 100 miles per hour heading west. Now we have to consider the left to the right to the left. We're going to take train A as being our reference, and train speed is to the right. We'll think of that as positive, and train B speed is to the left, and we'll consider that a negative because the two trains are approaching from opposite directions. Now let's develop an expression that relates train A's distance in terms of the speed and the time that transpired, and this is a well-known expression that we've been working with for several weeks now. The distance traveled is equal to the velocity times time. Now, when I work this problem, I'm going to give train the head start because it says here that train A is going to leave Bridgeton traveling at 90 miles per hour, and then at 12:15, okay, starting at noon, at 12:15, 15 minutes later, train B leaves Cogsville heading west toward Bridgeton at a speed of 100 miles per hour. So what I'm going to do is consider this distance here, the head start of train A, and let's calculate what that distance is. Okay, so distance is equal to velocity times time. So distance is equal to 90 times 15 minutes. Now, our units are miles per hour. 15 minutes is a quarter of an hour, so we need to consider 15 as 0.25. So we have 90 times 0.25. That gives us a distance of 22.5 miles. Okay, 22.5 miles. So train A has a head start of 22.5 miles. Now, the distance between train A and train B is 450 miles. So the total distance between train A and train B is 450 miles. But since train A has a head start of 22.5 miles, the time at which train B leaves Cogsville, train B is, let's put it down here, indicate it, is 427.5 miles. Okay, does that make sense? Okay, so we have 427.5 miles plus 22.5 miles gives us the total distance of 450. That's the distance between the trains when they started out. But since train A has a head start of 22.5 miles, it is at this point in time that train B is going to leave Cogsville heading west, and we want to find out when the two trains meet and where the two trains meet. And that's sort of the operative here. Although the problem says at what time, so we're eventually going to find out when they meet. Now, we have to develop two different expressions, two algebraic statements that relate the distance traveled for each train. So for train A, let's give it an expression, dA, this is the distance that train A has traveled east, is equal to VB, that's the velocity of train B times time. Now, train B, let's give it an expression, the distance traveled is going to be d sub B, and that's going to equal velocity of train B times time, And then since train B is technically 427.5 miles to the right of train A, we're going to give it a distance. Okay, we're going to give it that distance of 427.5. I hope that makes sense, because we're going to consider train A as being the origin or the time at which train B leaves Cogsville heading west. We're going to consider train A as being has started out at 0 distance, whereas train B is to the right of train A, distance of 427.5 miles. Now, you need to consider that the speed of train B is directed to the left, so when we substitute 100 in for v sub B, that's going to be a negative value, so heads up. All right, we know that they cross each other at the same place, so that being said, we're going to set the distance that train A has traveled equaling to the distance that train B has traveled. So hopefully this makes sense. So velocity B times t is equal to VBT plus 427.5. Now, let's substitute some values here. We've got 90 times t is equal to negative 100 times t plus 427.5. Let me make sure that let's get that 27.5. Solving for t, we get 190. Okay, we're going to add 100t to both sides. 190t is equal to 427.5. Therefore, t, this is the time, is equal to 2.25. Now, that's 2.25 hours. Okay, that's 2.25 hours. So over here in this little space, we're going to consider the time at which train A left, or the time that train B left was 15 minutes later after train A is left. We're going to add 2.25 hours to 12:15. Okay, so be careful here. I'm going to add 2.25. Now, 2¼ hours is also 2 hours and 15 minutes. Okay, and we're going to add these up. So, at 1 hour afternoon, you get 1 o'clock. So here's 2 hours added to 12 is what? 2 o'clock. Okay, does that make sense, folks? And then 15 minutes plus 15 minutes is 30. So here we have it. So they're going to meet at 2:30 p.m. All right, so there's your example final exam problem. All right, have a good evening.